We will start with matrices, but I'm not going to go over everything in the tutorial. I have explained everything in detail. There are many examples, and I hope you will follow the examples. First, you're going to read the description, and then you're going to follow the example. And don't just follow the example. I want you to do the example, create the programs that are shown in the examples, and then see if your results will match my result. In that way, you will not only get extra practice, but you will know that you're doing things correctly. So matrices is where we're gonna start lecture number 2 for MATLAB. Again, I'm not gonna go over everything. Matrices are very similar to vectors. The only difference is that matrices have multi-dimension and vectors had only one dimension. So go over everything in the tutorial, see how we create matrices, how you can modify matrices, and some other functions that are related to the matrices are given. Some of the special matrices you can create in MATLAB, like matrix of all ones, matrix of all zeros, identity matrix that has its leading diagonal to be 1 and rest of them to be 0. There are two very common functions of matrices that you're going to be using, I think, many times, not only in this course, but also in some other courses, including circuits course and other courses. And those two functions are inverse function and determinant. And these functions are operated on matrices using INV and DET. If you're taking math class, advanced math class, EGN 3428, you're going to discuss matrices, you're going to look at the inverse function, inverse of matrices, and you're going to look at the determinant of matrices as well. So let's see, I'm going to let you, of course, study all of this. Everything is given in detail. And I'm gonna go ahead and example number 5 is one of the examples. Again, do the example, write the script like I'm writing, run the scripts and see you get the correct answer. So this is one method to solve linear simultaneous linear equations. We discussed in LabVIEW about simultaneous linear equations, and we used matrix inverse function to solve simultaneous linear equations in LabVIEW. There are generally three methods that are used to solve equations. One method is substitution method, the second method is Cramer's rule, and the third method is matrix inverse method. And in Cramer's rule, this is a program that calculate the value of x and y from these two equations using Cramer's rule. Again, at this time I don't want to go over what Cramer's rule is. If you don't know what Cramer's rule is, I hope many of you already know what Cramer's rule is, but if you don't, just Google it, just search online, you will see how to solve equations using Cramer's rule, and then look at this program and it will make perfect sense to you. Exercise 5 is not one of the exercises that you have to do for homework, but there's an exercise which is similar to exercise 5 that you will have to do for homework. So let me go ahead and do exercise 5 really quickly for you. It's not part of the homework. So we have two linear equations, the same linear equations I'm assuming that we have here. 5x plus 7y is equal to 10 and 4x plus 2y equals 3. So I have 5x plus 7y equals 10 and 4x plus 2y equals 3. And how to solve for x and y values using matrix inversion is shown over here. So how do you create this program? If you look at it, exercise 5. The first thing, of course, when you're submitting your homework, make sure you do the comments, exercise number, your name, homework number, and all those things as the comment. A good practice is to start your program with CLC to clear the command window, and clear to clear all the variables. That's a good practice to do, except when you're writing functions. When you're writing functions, you do not use clear, and functions we're going to discuss later in this course. So I'm going to define matrix A as the coefficient matrix of x and y. So 5 and 7, you can either put a comma between the elements of a row, or you can leave a space. It will be the same, 4 and 2. So that's my matrix A. I'm gonna put a semicolon so it will not print the value of A. And then I have the matrix K, which is the constant vector on the right hand side, which is 10 and 3. So 10 and 3. When you're writing a column vector, or when you're changing rows, then of course you put semicolon. Another way to write a column vector, easy way, perhaps if you don't want to press the semicolon over and over again, if let's say if you have 4 different rows, you don't want to press semicolon over and over again, and you are writing a vector, just put a row vector and then put apostrophe to convert this into a column vector. This is going to convert into the column vector. It's going to take the transpose of the vector. Transpose means converting rows into column and column into rows. And to solve for x and y, let's assume that my x variable represent a vector that contains x and y. So that's going to be inverse of A according to this operation, inverse of A times K. As simple as that. Also, when you are solving linear equations, another way you can solve the same operation is by using backslash. So instead of using forward slash, use backslash. What is backslash? Okay. That's also an easy and actually more efficient way in MATLAB to solve the linear equation using matrix inverse. It's going to perform the same operation as inverse of A times K. And another method is just take A inverse times K. All of them should produce the same result. So let's go ahead and run this and see if you get the same result. Save. And this is exercise 5. Now make sure when you're solving, when you are saving the program, you need to save it as your first name underscore last name underscore exercise 5. This is not one of the exercises that you're submitting anyways. So if I go ahead and run this and open my editor, it's giving me an error. Let me see. 9.4. Did I use backslash or forward slash? Let me see. I use forward slash, that's why, instead of backslash right here. Backslash. Okay, here you go. Alright, so x, x1, x2, as you can see, all of them are same. The value of lowercase x is 0.055 and y is 1.388. If you want, you can separate the values. If you, let's say you have to print the values, you can say x is equal to x of 1, so first value is x, and y is equal to x of 2. And then you don't have to show anything. So when you run it, it's going to show you that lowercase x is this, lowercase y is this.